Mining has always played a crucial role in the development of human civilizations. For centuries, the success of gathering the necessary raw materials relied on basic tools and sole manpower. Nowadays, in most of the mines, we can find less people and more machines. But there are mines where exploitation is considered as uneconomic due to the small size of the deposits or the difficulty to access them. Several European research institutes formed an alliance to overcome this problem. They are developing technologies for autonomous mining, which will enable extracting materials from small and hard-to-reach deposits with minimal impact on the surface. During the first phase of the ROBOMINERS project, the aim was to create models and test various ideas. To develop new sensors was a hard task. Not to mention how difficult it was to deal with the Archimedes screw as a propulsion system. The models were working fine, so it was time to elaborate the concept. Mežica mine in Slovenia is a perfect site to test the geoscientific instruments. Laser-induced breakdown spectroscopy, or LIBS for short, is an analytical method where focused laser is used to create plasma on the targeted surface. The wavelengths and intensities of the emitted light show the element composition of the targeted material. This instrument, which is created by the ROBOMINERS team, is not just capable of telling the element composition of a given point, but it can scan a defined area with rapid measurements, creating an element map. As we can see, the results are nicely reflecting the pattern on the wall. The LIBS can only detect what is on the surface, but there are devices that can see through walls. The electrical resistivity tomography can tell the subsurface boundaries of minerals by measuring electrical resistivity changes. The depth of detection depends on the distance between the electrodes. Conventionally, the electrodes are meters apart, but to guide the drilling head, better resolution is needed while shallow detection is acceptable. The results refer to the changes in mineral composition inside the wall. So basically, the robots will know how to follow deposits. But it's equally important to be able to monitor the quality of the mined minerals. At the laboratory of QTech in Germany, members of the ROBOMINERS team are working hard to find the solution. The mined material will be transported to the surface mixed with water as a slurry. As we have seen, LIBS is a fast enough method to be used for continuous monitoring. But there is a problem. Slurries are notoriously not transparent, and a transparent space is needed for focusing the laser and detect the emitted light. As we can see, the LIBS is working fine on the surface of the slurry. The solution is to create an air chamber with a glass window in the pipe that carries the slurry. Thanks to 3D printing, it's easy to test different ideas. The perfect air chamber is hard to create, as its window has to remain clean and the level of the fast-running slurry needs to be constant so the laser can hit it.
Alright, let's try this.
Finally, everybody thinks they found the right setup. It's time to give it a try. The system is running, the level is fine, and the window remains clean enough. It's a laboratory experiment, so they add salt to the circulating slurry to be detected by the LIBS. The peaks on the screen show that the idea is working, at least in the laboratory. But mining is messy, so final tests are to be carried out in a realistic environment. In our case, it's the Kunda mine in Estonia. So far, we've only seen different devices which are needed to construct the robot, but not the actual prototype. Meet the RM1. In the RM1, all movements are powered by water. The hydraulic system drives the Archimedes screw, spins the drilling head, and moves the working cylinders. The coordination of the movements is controlled by computers via numerous electric valves. To be able to precisely drive this robot and to create enough force where it's needed, the water pressure has to be regulated in each hose and each cylinder of this sophisticated machine. The RM1 easily reaches the right position for the very first drilling. The drilling tool has been developed specifically by the ROBOMINERS team. Looks effective, but the excavated material needs to be transported to the surface. Since the robot is designed to work underwater, the easiest solution is to use water for transportation. The pump for this system also works with water. It's a so-called Venturi pump, where high-pressure water is injected to a suction head to carry the slurry. The pipe delivers the slurry to the monitoring unit where the libs can directly analyze its composition. Whenever the laser hits the surface of the slurry in the pipe, we can see the unique waveforms of all the elements it contains. All the systems work fine, so the ROBOMINERS team successfully proved their concept is viable. Computer simulations demonstrate how the robotic miner would operate. It's still a long time until mining robots like the ones they've created took over the hard work in the industry. But these results are guiding us towards the future of mining.